Hello, everyone, and welcome back to Calculus. So today's lesson is over the area between curves. So what we're trying to do is we're trying to figure out how to find the area that's between two graphs rather than the area under a single graph, which is what we've been doing with integrals. So for an example picture, right, I've got these two functions, and I want to find the area that isn't just underneath one of them, but it's under the green graph, but above the blue graph. So I want to kind of take what we've been learning about integrals so far and be able to adjust it to handle this new situation. Okay, so if I think about that picture that we were just looking at, where I had an area below the green graph and above the blue graph, then if I think about that for a while, I could rewrite that area as if I took all the area that's underneath the green graph down to the x-axis. So I kind of overshoot it a bit, take too much area, and then I subtract off the excess area that I just threw in. So if I sort of overcount my area and then get rid of the excess, then I really would be just left with the area that I cared about. And if we look at these two pictures on the right, these are things that we already know how to handle, right? So on the right, this would be so this first picture is the integral under sorry, I'm overthinking things a little bit here. Let's mark this as A. Let's mark this as B. It's called the green function f of x. And let's call the blue function g of x. Okay. So all of my pictures are going from A to B. A to B. Okay, so with our notation now, we can rewrite each of those areas as an integral. So that first one is the integral from A to B. This is the area under the green graph. So this is the area under f of x dx minus the integral also from A to B. And then that's the area that's just under g of x dx. And if you remember our properties of integrals, we don't have to do these integrals separately. We can combine them. So really, in total, to find our full area that we originally cared about, that was between the graphs, what I can end up doing is I can take the integral between A and B of the top function minus the lower function. Right, so this area, top function, as far as like, even if I look in the shaded region, the function that is on top is f of x, and the function that's below is g of x. So that's why I end up with the order take f of x and subtract off g of x. And that is going to be our general idea. Anytime we're finding area between some upper function, u of x, and some lower function, sorry about that movement. So anytime we're trying to find the area between some upper function and some lower function on some interval a to b, then the integral that you need to set up is you should integrate from a up to b and take your upper function minus your lower function dx. Okay, so let's see an example of this. So we want to find the area between the graphs of y equals x squared minus 4x plus 4 and y equals x plus 5. So first thing I would think about is I would graph my picture, and I would make sure to sort of clearly think about what area it is that I'm trying to find. So it looks like I'm trying to find this area. Okay. And doesn't look like I quite have the bounds to be pretty nice numbers, so I'm gonna have to do some working to think about what my bounds should be. But what I do know for sure already is which is my upper function and which is my lower function. So my upper function is the green function. That was the graph of x plus 5. And my lower function was the graph of x squared minus 4x plus 4 dx. Careful about your parentheses. Make sure you subtract all of the lower function. Okay. So other than, finishing out this integral and anti-deriving and all that, the other big thing that we need to do is we need to find our a and our b values. And if you think about it, that's just a pre-calc question. That's the places where our two graphs meet. So finding a and b, it's where y is both x squared minus 4x plus 4, and y is x plus 5. So we need x squared minus 5x minus 1 to be 0. And you can try to factor this. I'm not seeing a nice factorization, so to me that says it's probably a quadratic formula question, right? So x is going to be equal to the opposite of b, so 5 plus or minus the square root of b squared minus 4ac, 4 times 1 times negative 1, all over 2a. And so simplifying down, what this says is, so those are my two roots, so those are going to be my a and my b. And a is the smaller root, so I'll take the subtraction with that. So a should be 5 minus root 29 over 2. And b should end up being 5 plus root 29 over 2. So again, to find the places that you should integrate between, just set your two functions equal to each other, solve like you know from pre-calc. Okay, so let me move that part out. So I can go ahead and plug in my bounds now. So I'm going to integrate from 5 minus root 29 over 2 up to 5 plus root 29 over 2. Of that function. And if I integrate my function, so to see my antiderivative, I'm going to clean things up a little bit. So factoring in my minus sign, I end up with minus x squared plus 4x minus 4. And so really, I'm looking at the integral of, let's see, negative x squared at 5x's in here, plus 5 minus 4 is a plus 1. So just cleaning up the inside function in my integral gives me this. Oh, plus 4x. I already cleaned that up as well. Okay. There we go. All right. So when I antiderive, that's the function that I should find my antiderivative of. And so I should be taking 5 halves x squared plus x minus 1/3 x cubed plus c. That's my antiderivative. And I should plug in my two roots. Right about here is where things get super messy because of our values for A and B. So this is where if you're wanting to get a nice numerical answer that gives you some intuition, go ahead and just plug this into your calculator. So plug in 5 plus root 29 over 2 into this function, plug in 5 minus root 29 over 2 into this function, and subtract them out. Okay, cool. So that is our first example of finding some sort of area between the graphs of two functions. We can also talk about maybe doing area between multiple graphs, so not just two, but maybe 3 or 4 or whatever. So in this problem, we're asked to find the area between the graphs of y equals e to the x, y equals 1 over x, and x equals 2. So if I think about that, if I graph all of those things, then I get this picture. So e to the x being the blue graph, x equals 2 being the black graph, and 1 over x being the green graph. And if you look at the space that's actually bounded by those pictures, the only space that's like actually in between all of them and is a finite space is really that piece of the graph. So that's the piece that I'm trying to find the area of. So based on that, I can start setting up my picture. So I'm going to be going from A up to, thankfully I know my B value this time. My B value is 2. So I'm going to integrate from some value A up to 2. And then I'm going to take my upper function, which again, in this region, the function that is higher up is going to be the e to the x. The function that's lower down is the 1 over x. So I'll take my upper function minus my lower function, dx. Again, I need to figure out what that value of a is. And that's going to be a place where my two graphs intersect. So I know that I want 1 over x to equal e to the x. And let's see, that's not going to be a super nice number. So this is where I would suggest, again, pulling up some sort of calculator, right? And asking it to find where 1 over x equals e to the x. And sorry, I'm asking for the nice number and it's not giving me. Okay, there we go. So in this case, what it's saying is that I should get A being about 0.5671. Okay, so now I can set up my bounds. So that is my lower bound on my function. So I'm going to go ahead and plug that back in up here. So I should be integrating from 0.5671 up to 2. And I'm integrating the function e to the x minus 1 over x. All right, at this point, this is an integral that we know how to do. So we're going to take the antiderivative, which is e to the x minus natural log of x plus c. We're going to plug in our bounds of 2 and 0.567. And so at the end of the day, you should get e squared minus natural log of 2. The c's will cancel, minus e to the 0.5671 plus natural log of 0.5671. 0.5671. There we go. And again, not a super nice number that I would expect you to be able to simplify by hand or anything. Plug this into a calculator, get a nicer number out. Okay, so it's your turn. So I'm asking you to find the area between the graphs of y equals 1 over 1 plus x squared and the graph y equals 0.5. So go ahead and pause here and try this problem yourself. Hopefully you actually paused and tried it, but I claim the answer that you should end up getting. Note when you antiderive this, the antiderivative of that is tangent. So you should end up getting, or sorry, arctangent. So you should end up getting that your answer will be arctangent of 1 minus arctangent of -1 minus 1. All right. Great job, y'all.